Hi to everyone. Myself D. Rajitha. I am working as assistant professor in the EC department and in the College of Mlritm. Today we are going to learn about types of the radar systems. The radar stands for radio detection and ranging. The radar system is an advanced electronic system using modern radio wave technology to determine the directions, measure the distance and velocities of the object with respect to their locations. The radar systems are known for their accuracy measurement. Today, these systems are playing an important role in various fields, from air traffic control to ships, navigation, space exploration, and weather forecasting. A radar system works by transmitting electromagnetic waves and analyzing their reflections. Historically, radar systems were developed for military application during the World War II. The modern radar systems are being used along with the advanced technologies like digital signal processing, artificial intelligence, and machine learning to provide more precise and reliable operations. The principle of a radar system: the radar system operates in a way that it radiates electromagnetic energy into the space or environment and detects the various aspects related to the objects by analyzing the echo generated when the radiated energy gets re-radiated by the object. The radar works by sending an electrical signal which is transmitted via the environment or space. On the pulse track, objects are recognized as targets will disperse nearly all the energy, but few are diverted back to the radar. The targets then scatter the signals, combine into the receiver to develop a strong signal as distributed radiation would go into it. This figure shows the principle of a radar system. In this, we have transmitting antenna and receiving antenna. By using the transmitting antenna, we can transmit the electromagnetic signals or electromagnetic waves into the space or environment. These electromagnetic waves are come back from the target as echo signals. These echo signals are received by the receiving antenna. By using these echo signals, we can determine or we can easily identify the target range as well as distance of the target. So the electromagnetic signal is produced by the transmitter unit and is radiated in space by the radar antenna, while the receiver performs extraction of the information from the signal received by the radar antenna. We know whenever the electromagnetic wave is transmitted by the system, then it reflects and re-radiates the sum of its parts and experiencing a variation in the conductivity of the medium. This variation in conductivity arises due to the presence of an object, either stationary or moving, thereby producing an echo. The radar system receives the echo by the help of an antenna in order to analyze it and have the location of the object. Now the question arises how the reception of an echo signal can determine the range and location of the target. The range of an object is determined by the measurement of time taken by the radiated signal to reach the object and come back to the radar. And the location of the stationary object in the space is determined from the angle pointed by the antenna when the echo received is of maximum amplitude. For a moving object, because of the Doppler effect, there exists a shift in the frequency of the re-radiated signal or reflected signal, and the frequency shifts show the proportionality with the radial velocity of the object. These are the parts of the radar system. In these parts, we have duplexer, transmitting antenna and receiving antenna, signal processor, and display unit. The antenna unit means it comprises of two main components, namely radar antenna and electric motor. The antenna radiates the radio waves to the objects and receives the reflected waves from the objects. The electric motor rotates the antenna in a specific direction to ensure reliable tracking of the objects. Next one is transceiver. It acts as the heart of the radar system and consists of transmitter and receiver. The transmitter is responsible for generating and transmitting radio or microwaves, while the receiver is provided to receive the reflected signal from the object. The transmission and reception of radio waves take place through the antenna unit. Next one is duplexer. The duplexer, it is a device that provides a bidirectional flow of signal through the single path. In radar system, it is used for isolating the transmitter and receiver while allowing them to share the same antenna. And the fourth one is signal processing unit. This is known as the radar processor. This unit is responsible for analyzing the signals received by the receiver unit to determine the distance, velocity, and directions of the object. And next one is display. This component of the radar system provides a visual representation of the result produced by the processor unit. It shows the information like distance, velocity, movement patterns, current position, etc. of the object. And next one is types of the radar system. Depending on the scanning pattern, configuration, and application, the radar system can be classified into different types. They are monostatic radar system, bistatic radar system, monopulse radar system, Doppler radar system, passive radar system, pulse radar system, and continuous wave radar system. The monostatic radar system means it is a type of the radar system. Single transmitter and receiver combinedly use the same antenna for transmission and reception of the electromagnetic signals. These radar systems are mainly used in applications like air traffic control monitoring, weather conditions, and surveillance, etc. In figure shows the same antenna for transmission purpose and receiver purpose. Bistatic radar system. In a bistatic radar system, the transmitter and receiver are located in two different locations. The distance between transmitter and receiver is kept equivalent to the expected distance from the targeted object. This radar system is mainly used in long-range military or weather-related applications. And third one is monopulse radar system. A monopulse radar system is an advanced radar system mainly used for measuring the angle of the target and tracking applications. This radar system can determine the distance and the angle at the same time by using a single pulse. And the fourth one is Doppler radar system. The Doppler radar system is a radar system that uses Doppler effect to calculate the velocity of a target object. This radar system works by sending a microwave signal towards the object whose velocity to be measured, and then it analyzes how the motion of the reflected signal has changed. The Doppler radar system finds its usage in applications like radiology, healthcare, military, and aviation, etc. Next one is passive radar system, a radar system that uses signals produced by the source in the surrounding environment like communication or broadcasting channels for measuring and tracking purposes is called a passive radar system. In this radar system, no dedicated transmitter is used. Next one is pulse radar system. A pulse radar system is one which works by transmitting a powerful pulse of high frequency towards an object and waits until the reflected signal is received from the object before sending the another pulse. The direction of object using pulse radar is based on the concept of Doppler shift. And seventh one is continuous wave radar system. The continuous wave radar system works by sending and receiving high frequency radio continuously. The working of continuous wave radar is based on the Doppler frequency shift produced by moving objects. This diagram shows the block diagram of a radar system. In this block diagram, we have two sections. First one is transmission section and second one is receiver section. In transmission section, we have waveform generator, power amplifier, pulse modulator, and duplexer. In receiver section, we have low noise RF amplifier, mixer, local oscillator, IF amplifier, second detector, video amplifier, threshold decision, and display unit. The transmission section is composed of the following units. They are waveform generator. The waveform generator generates a radar signal at low power which is to be transmitted into the space. Next one is transmitter. The signal generated by the waveform generator is fed to the transmitter. The transmitter section can be a magnetron, traveling wave tube, or a transistor amplifier. In the case of the pulse radar, magnetrons are widely used as the transmitters, but whenever there exists a need of the high average power, then amplifiers are used. Third one is pulse modulator. A pulse modulator is used to build synchronization between the waveform generator and the transmitter. The pulse modulator causes the turning on and off of the power amplifier according to the input pulses generated by the waveform generator. Next one is duplexer. A duplexer is basically used to form the isolation between the transmitter and receiver section. A duplexer allows the use of the single antenna for both transmission and reception purpose. However, both sections operate at different power level. Therefore, a duplexer is used to isolate the two sections. Thus, the signal from the transmitter is provided to the antenna through the duplexer only. Next one is receiver section. The following components are present inside the receiver sections. They are low noise RF amplifier. The receiver must be a super heterodyne. The unit acts as the input stage for the receiver section. The RF amplifier generates the RF pulse, which is proportional to the echo of the transmitter signal. Mixer and local oscillator. The RF pulse received from the low noise RF amplifier is converted into IF pulse. Usually, the RF amplifiers acts as the input stage of the receiver section, but sometimes mixer acts as the input stage by the eliminating the RF amplifier. But this leads to less sensitive receiving section due to the high noise figure of the mixer. And next one is IF amplifier. The IF pulse generated by the mixer circuit is amplified by the IF amplifier. It acts as a matched filter and increases the SNR of the received signal. Also, it enhances the echo detecting ability of the receiver section by reducing the effects of unwanted signals. Second one is demodulator or second detector. This unit is nothing but a crystal diode that performs the demodulation of the signal by separating the transmitted signal from the carrier. Video amplifier. This unit amplifies the received signal to a level that can be displayed on the screen. Next one is threshold decision. This unit makes the decision about the existence of the target in space. Basically, it has some threshold limit set which is compared with the magnitude of the received signal. If the threshold value is surpassed by the output signal, then this shows that presence of the target. Otherwise, it is assumed that only the noise component is present in the space. And last one is display unit. The display unit shows the final output of the receiver section, that is plan position indication is typically used as the radar display unit. It presents the range and location of the object by mapping it in polar coordinates. The output signal modulates the electron beam of the cathode ray tube in order to permit the electron beams to sweep from the center in outward directions of the tube. And the sweep shows rotation in synchronization with the pointing of the antenna. And next one is advantages of the radar system. The long range detection, all weather operations, reduced dependency on light conditions. And the fourth one is measurement of speed. Fifth one is tracking a target. And sixth one is adaptable applications. Seventh one is constant monitoring. Disadvantages of a radar system. The maintenance and implementation cost is high. Complexity of processing the data. And third one is interference in crowded electromagnetic conditions. Fourth one is potential for signal absorption by rain. Fifth one is privacy concerns. And sixth one is altitude resolution is limited. Applications of radar system. First one is the military surveillance, ground-based monitoring, air traffic control, weather conditions and observing determining. Fifth one is aeronautics weather conditions checking. Sixth one is navigations and impact aviation. Seventh one is search and rescue operations. Eighth one is space surveillance. Ninth one is traffic control and enforcement. 10th one is wildlife life monitoring. Thank you. In next class, we will discuss about radar range equations.